Hello and welcome to Automation Talk, and we're glad that you're joining us today to watch our Productivity 3000 Advanced, and this is number 2. Who knows how many of these advanced ones we'll do, but I think Tom's put together a really good show today with some of the advanced programming. So without further ado, I'm going to go ahead and just hand it over to Tom and let him start out, and we'll go through his demos and whatnot. So.
Okay. And basically, Shane, we this is Advanced 2, and it looks like we have room to probably do an Advanced 3 and probably an Advanced 4. When you and I were starting to plan this and everything, and we were getting into the instruction set, we said we definitely wanted to do something with DataWorks and explain some kind of, use of data from a PLC to get it back into a database and use it for production type systems and everything. And after we got into that, we kind of realized that was going to take most of today's 45 minutes of activity on the show. If you want to go to the next slide, we'll real quickly cover the hardware, but today we're talking about our Productivity 3000. It's a programmable automation controller. It's modular, rack-based footprint. The CPU has 7 built-in communication ports. We have both local and remote ability for I/O expansion, and of course the CPU has 50 megabytes of user memory. And I'm not going to go too much into hardware because basically, if you want to learn more about the hardware, we have a couple other pre-recorded webinars out there that basically cover the hardware in more depth. If we go to the next slide, basically we'll cover the hardware a little bit more here, but the controller modules, CPU has local and remote expansion. The CPU and all the remote slaves also have an LCD display that allows both status and configuration information to pop up, but they're also user programmable. We carry both AC and DC input power supplies. There's no power budget restrictions like you might find on some of our other PLCs. The I/O modules are hot swappable, and then we also have the optional terminal blocks or the easy-to-use zip-link solution. And if we go to the next slide, we'll get into what instructions we're going to try to cover today. Not try, we will cover these today. And basically the first one we're going to cover is the DataWorks P3K. It's a utility that's done by BizWare that allows us to pull and extract data from different tag names within the Productivity 3000 and basically populate it into a database. To start with, if we go to the next slide, we'll get into the what we're going to cover here, but basically let me grab the mouse if you want to switch over to the software screen. The demo software, the first thing I'm going to bring up is the database on the software. There we go. And what I'm using is Microsoft Access. And I should point out as we go through here, there's several steps to set this whole database scheme up and everything, and kind of listed them there on the slide. So we're going to create the database, then we're going to create our project, and actually those first 2 steps they can actually be swapped around. And then we're going to start the DataWorks server. Then there's also a DataWorks monitor that allows us to connect to the server, and we're going to configure the DataWorks server, and then within the monitor we're going to create a device procedure, and we can create dozens or hundreds of different procedures for what we want to do with the data. And then from there we'll export the procedures to a configuration file that we'll be able to use back within the Productivity 3000 software that will allow us to create a DataWorks request. And then finally we're going to test it. So to preempt this a little bit, let me explain what we're trying to do here. If you switch to the screen on the trucks, try to explain what our operation is going to be. So we came up with this project, and you'll see in front of us here a bunch of little toy dump trucks. And basically, these are going to be Smiley's dump truck assembly line. And in this process, each vehicle, each dump truck, will have a barcode on it. That'll become our VIN number, or vehicle identification number. And basically what we're trying to do in our production line and everything is when we install the dump bed on the truck, there's going to be an axle on each truck, and within that axle will be a couple of bearings, and those bearings will be assembled, but because of differences in tolerances and everything else, even though manufacturing tries to manufacture parts that are totally interchangeable, there's always some adjustment required. So during the assembly process, we'll get this all together, and then we'll actually, with a proximity sensor that senses distance, we're actually going to measure what we'll call the end play of that axle and the bearings, and at the same time we're going to also check the temperature of that axle, because metal, of course, contracts and compresses and retracts based on temperature, and from those numbers, we can calculate how much preload we need to adjust on those bearings later in the assembly process. So the whole purpose here is to record that information along with the VIN number of the truck, but then also we want to be able to time date stamp that and keep a record of it. So for record keeping, we can put all this information into our database, which we'll demonstrate, and then we can also take that information and put it on the final assembly line for the truck to let the technician that's going to set up that dump bed on that truck to adjust the preload on the bearings. So to get started, if we switch back, the first thing we're going to do is set up a database. I'm not a database expert, so if we go back to the software screen, basically I'm in MS Access. If we go to the next slide, we'll see that we're in our design stage. So here I've created an ID number that is basically an auto number that's going to keep track of our record. Built into Access is the time and date, so my type is date and time. And then there's three variables that I'm going to extract or pull from the PLC, and one of them is going to be my temperature. And so in our case, and let me explain real quick up here, if you wanted to zoom back to a full out of all the equipment, if we got that scene, so I can explain the equipment real quick so we know where we're at. The main CPU is to my right. Get my left and rights mixed up here. But on my CPU I have a 8-slot rack. There's 4 different slots available for the P3. So we got 3s, 5s, 8s, and 11s. So I got an 8-slot with my CPU. And I also have, just for grins, I have some local expansion, which requires just a USB connection. And then also off of my CPU, there's 2 basic Ethernet ports. One of them's for Ethernet communications back to the PC and also to my Seymour I have down here on the very end. And the second port is for remote I/O. I've taken both of those and I've actually used Ethernet cable to go to a couple Stride switch hubs, mainly so I can expand these to other equipment. So the remote I/O, I use that to go to the rack, the 2 racks that are down there by Shane, and I think the top one's 11, and in that's a remote slave expansion module. And then off of that with a USB cable, we also have a remote slave. So we have kind of a full boat of 1 CPU, 4 racks, some local expansion and remote expansion. So what's great here is I actually have my Seymour tied into the Ethernet port hub where I'm talking to that from the CPU, but then I'm also taking my temperature, my distance, and my barcode, and I'm actually running my barcode through an RS-232 port on that remote slave expansion rack, and that's all communicating back. So my temperature, I have that set up as let me back up my time and date, I actually put a default value of now, and that's built right into Access. And if we go back to the software screen, I'm kind of wiggling the mouse pointer over it, but I actually had to set that variable in this table and everything, so the date we want to pull in is now. My temperature, I'm actually using a single floating point value, and I'm using a standard format, which gives me 2 decimal places. My distance, I'm also using a single floating point value with 2 decimal points. And then, of course, my VIN barcode number, that's a text. I'm using 12 digits. If you look at the barcodes when we bring them up, I kind of came up with this 1 ADC for our company, the year 2010, DT for dump truck, and then a 2-digit serial number as part of that, and that's where that 12 comes from. So once I get my Access database all set up, I've saved it as a file, and now I'm into the data record view, and as you can see here, we've actually already captured some data, and we've actually deleted some, so we're already all the way up to record 98. But that kind of, if we go flip through the slides a couple more times, we'll see there's the actual design view, then one more slide, I think. Yeah, and then, yeah. And now the next step we get into is actually setting up what we're going to do in the Productivity3000. And the first thing I want to do is I set up 3 different tasks that I want to do within my Productivity3000. The first one, I want to bring in my analog values from the temperature, which is a 4 to 20 milliamp output going into an analog input module, and it's going to give me, if I remember right, if we bring up the scale value, oops, that's my distance, let me get down on the temperature. It's 4 to 20, which represents 0 to 20 would give you 0 to 65,565 counts. Since we're doing 4 to 20, if you did the math and everything, you'd find out the min for 4 milliamps would be 13,107 counts. So my output on that particular sensor, that's a ProSense temperature sensor, will give you 32 to 212 degrees F. I stuck with F even though probably in most production areas and everything you'd be using centigrade, but I kind of liked using F for our little example here. So that was my scaling to get my temperature. So I'm actually bringing in that value from that analog output card, and my output I'm calling temperature. So right now you see a correlation where we've actually taken the temperature, we called it temperature, and then in our database we have a variable there we call temperature. Both of them are set for floating point. Technically I don't have to call them the same name, and I'll show that when we set up the DataWorks configuration. In my case it was easier to try to keep similar names so we could match them up when we set up the database. Then in our distance, we're going to measure the end play on our bearings. We have one of our ProSense, the analog sensor, but it has an analog output of 0 to 5 volts with a range of 0 to 10 millimeters, or 0 to 0.39 inches. I stayed with inches, so if you look at the scaling here, we went from 0 as our input to a count of 32,767. And our output is 0 to 0.39 inches, and that is in floating point also. So that's how we got our scaling. The second thing we needed, or the piece of data we needed to get into our spreadsheet and everything, was going to be our barcode. So basically, I've used the ASCII in instruction within Productivity3000. I'm using the RS-232 port on the remote expansion, so I've identified that. I'm going to go with a fixed length of characters, so I'm using 12. And my definition for this, I just named it barcode data. You'll notice later when I map the PLC tag name over to the DataWorks names. Here we're calling it barcode data, but in DataWorks we're actually calling that our VIN barcode, and we'll see that. I also set up all the flags and actually use some of those flags to trigger our DataWorks request. So when we scan with the barcode, if I see a successful scan from the barcode, of that barcode, I actually use that signal to trigger the DataWorks request to go get that information and bring it into the database. And then also here, if you can see this, I put a little clear barcode flag on the CMOR over here, and I actually clear out that ASCII text data register just to clean it up for starting purposes. So that pretty much takes us through step 2 that gets us the start of our P3K project. We'll come back because the third part of this is actually the DataWorks. But before we get to the DataWorks, we need to go to before we get back to the P3K, we need to go to the DataWorks and get the server running, and then we also need to get the configuration and set up our procedure. And then you'll see from the procedure we actually create a file that we bring back into and identify with the DataWorks request. So it's kind of like you start, if I can try to explain again, you need your database and you need a project. So, and either one could come first. Once we get them done, then we need to go to the DataWorks server and the monitor and get that all set up with the procedures, and then that information is used back in the Productivity3000 to actually do the request. And we'll cover that a little more. Next slide is where, oops, I think we're there. This is where we actually open the DataWorks. And in my case, I actually have all this already open. So if you look down here on the software screen, this is the actual server. The server actually resides on the PC. So the IP address I assigned here is actually it's actually a secondary Ethernet port that we have installed on the PC I'm using, and we actually used an IP address of 10.1.60.10. From here, I actually installed the server. I actually then started it, so I needed to be installed and running, as we can see here. This started out as a trial version that's free. It has a 30-minute limit. I went ahead and actually registered this internally so we could keep this on all the time. Once we got the server running, the next thing is we bring up the monitor. I already have it running, and when it first comes up, if you go to the next slide, it's going to show that basically it's not connected. So next slide, you'll see we're connected, and then the next slide, once we're connected, we're going to configure a server. And I already have it configured in my screen here. And go to the next slide, Shane. And once I say configure, when I select configure, I'm going to get the opportunity, and I think I skipped a step, and I apologize. Back in the Productivity3000, we set up the temperature, we set up the distance, and we set up the barcode, and we assigned tag names to all of them when we set up the instructions. And the last thing I should have done was exported that tag name database into a comma-separated variable file. And so we did that. So at this point, as shown on the slide and everything, I can actually import that tag name into the DataWorks monitor. So we would want to do that. So next slide, we show that. Here's where we would actually import it. And I went out and identified it, and I called it P3K Demo Advanced 2. When I imported it, it showed, I can't read the slide there, but it's like 747 records that actually came into the monitor, and then we saved it. The red arrow showing that you actually need to save that file. Next slide, I think we actually get into, here's where we start to configure. The first thing, let me bring up this on the screen. I'm going to say no. But up here at the top, I'm actually entering the IP address of the Productivity3000 CPU, and it is 10.1.60.23. I can assign an alias. I didn't in my case. And then the main thing is we can work with 3 different types of databases. We can work with Microsoft Access. We can work with SQL Server. SQL is sequential query language. And we can also work with ODBC, which is Open Database Connectivity. In my case, I already had Access on here. It was easier for me to set up a database and Access. So we selected Access. And then the next thing we wanted to do, since we had that database set up, and went out and browsed for it. In my case, it's P3K database. I'm using Access 2007, so the file extension's ACCDB. I can actually test the database. If I click here, it says connection successful. I'm already connected. Or where am I? Let's see. Okay, I'm connected. And then from here, next slide, I think we get into create a device procedure. I've already created one, but you would have collected or clicked add. And in my case, you know, it's showing we already added it, but I'm going to go ahead and say modify. And basically, every procedure is going to have a distinct ID number. And you have a choice of 4 different actions. In our case, we're going to do insert, which basically takes any of the information that we've collected through the barcode triggering the data works request, and it's going to populate a record in our database. We can also delete a record, we can also update a record, and then we can also select a record. So in our case, we're going to populate this database with all the VIN numbers of the trucks, get a end bearing, distance reading, and a temperature, and someplace down our production line, somebody else is going to select that record to get that information, and the calculation, it's going to tell them how to adjust the preload on the bearing. So in our case, I named this dump bed bearing adjustment. My whole table is called machine data. That's kind of important to know. And once I select OK and OK, that pretty much sets up our procedure. Now again, I can have multiple procedures. And every procedure I write, I'm going to have a separate data request within the P3K. And we're going to get to that in a second here. So the next slide just shows more of create the device. Same thing we showed. One more slide. And I guess, let me go back to it real quick. Let me go to the configuration. I'm not going to bring in the, oops, don't want to add. I'm going to bring this up, modify where here we go. Here's the mappings I talked about earlier. And if you notice, in the first field is actually the database name. So the table is called machine data, and in it I created temperature, distance, and VIN barcode. The tag names I imported from the P3K project I called temperature, distance, and barcode. I also set up the types of data. So I had 2 floating points and an ASCII or text file or text variable, and then I also under the text I gave it a length of 12. So that's pretty much how so far we've gotten everything down to this point. Next slide should show us that we're going to take our project and export it. So once I'm in the monitor, I can do an export, and the default on this, the file extension is DWX for DataWorks, and basically the file name reverts to the IP address of the CPU, because that CPU needs this information, and the data request knows how to assign the variables or values that are going over to it. So basically I kept it that way. It probably would be prudent to modify this file and put the today's date or some description with it. Next slide. Once we did this, okay, now we're back into the Productivity3000, and basically I'm going to open my, oops, that looked like more like my serial data. Here we go. So here's my data request instruction. I'm going to open that, and what you're going to see is I'm using the Ethernet port. My server IP address happens to be the PC where the DataWorks server resides. The database doesn't necessarily have to be on that same PC. It can sit out there in someplace else. And if you notice, my DataWorks project, the last thing I just exported from the monitor was 10.1.60.23 DWX. And then my procedure, I only created one procedure, and again, I could have multiple procedures, but it's the one I called dump bed bearing adjustment. And down here it's going to show the mapping that we initiated, and then there's also a SQL view that if you were doing sequential query language and you were typing this up to manipulate data in a database, this would be the exact instructions you would create. I also went ahead and put my status flags up here for in progress, and I actually used some of them to trigger some of this. So once we get this done, if you notice here, what I've done is to trigger that request, I've actually taken the barcode scan, the ASCII in instruction, and I have flag bits of ASCII complete and ASCII success, and I've used those bits to actually trigger the DataWorks request. And then once the DataWorks request is successful, I actually reset those two bits, and then I also, once they're reset, I actually then reset the success bit from the DataWorks. A little bit of a fly around and everything, but I think that covers everything. We have our trigger. Our trigger in this case, when we talk about trigger, our trigger in this case is actually the ASCII scanning triggering that request and everything. So at this point, we need to test the whole system, and I'll turn this kind of over and talk Shane through it, but he's my production manager.
So guys, I might get you to show in between me and say the Seymour panel as well, because that'll actually give some of the readings. Bump it over to the Seymour panel real quick, if you don't mind. All right, you'll see the distance actually changes there. So every truck, we actually have a different distance. Now, obviously, our temperatures here are going to be the same, just because you got ambient temperature. But I'm going to go ahead and scan this one.
Go back to Seymour, and again, there's our VIN number, which we just tried to be creative, and
so it's dump truck 04, right?
Yep, that's number 04.
All right, so we'll throw that one down. Bring up the next one. And this one actually has a little bit different distance.
It's our end bearing adjustment. Okay, did we change? Yep, that's 03, right?
Yes, sir.
Yeah, looking at the Seymour, we're on 03.
And we shove these down the assembly line, and we'll just do one more.
Okay.
That way I don't get accused of playing with toys at work.
It looks like 05.
Yep. And you notice that the distance on that one is a little bit different as well. So
yep.
all the end bearings have a different
distances. And Shane did a real nice job in setting up the trucks for
I like to play with truck
and temperature probing. Now if you switch back to the software screen and everything, we'll go back to our database, and this is our records. Now, again, I'm not that familiar with Access, but I do know that we won't get any updated records unless I click refresh. So we're up to 98. If everything worked, there we go. And we might have had one in there from an earlier time or a later time. Yeah, it looks like we did a couple earlier and I never refreshed it, or we were up here playing around, and actually somehow somebody scanned something that wasn't normal.
Yeah, I scanned a water bottle here.
While I was talking, I thought I heard some beeping going on.
So if you refreshed it again, it should probably bring up another. Yep.
Yeah, that water bottle has a correction of 0.22 inches. So. Anyway, as you can see, we have a record number, we have a date code, we have our distance, we have our temperature, and then we also have our barcode or VIN number and everything. All that information's in a database. It's, any kind of database you can actually manipulate it, change it, update it, move it to another file, and everything else. So that pretty much wraps up anything on the DataWorks request. I know it was a little bit convolutive as far as the steps, but I mean, you have a database, you create your database, look at the project you're trying to do, identify the data types and everything you want to get out of your project, assign tag names, export those tag names, start up your server, configure the server, and then import the tag names, of course, and then within the monitor, you're going to create a procedure. Once you have all your procedures, set for send, delete, modify, or whatever you want to do to those records, then you have a file you export that's used by the P3K data request. I mean, it's here, over here, and then back.
It's a very powerful tool, though. Yeah, it takes. I mean, it's not hard to do. It just takes some steps to do, but it's a very powerful tool.
And in comparison to a lot of the data type SQL server type stuff out there with HMI software packages, it's a lot more straightforward once you grasp the concept of setting up the files and everything. Next slide, I think we're going to wrap up here real quick. We've covered this once before, but here's where we actually created the DataWorks request. There's a couple slides here, and there's where we actually tested it. So we got through that. Last thing we're going to do is I'm going to reconnect. If we switch over to our liquid level control, I'd like to talk about the PID again. So I need to go out here and find our other CPU, which should be 1020 or 60.24, and we'll copy the project from there. We don't need to save that. And basically we have a liquid level control unit over here. We have our P3 550 CPU. We have a DC input, DC output, analog input and analog output, and basically all we're trying to do is use our PID with an ultrasonic sensor that has a 0 to 10 volt output. That's hard to see, but it's mounted over top of this round tank on top. And then we also have an analog output that drives a little Dart DC motor controller that actually varies the speed of a little water pump that's mounted on a reservoir tank under the whole system. And I guess I was really impressed with the fact, once we had this all set up and built, how easy it was to tune it and how accurate it's holding that level. Now, there's a lot of variations going on with this whole system. I mean, we're getting air in the water now and then, even room vibration. It's going to shake the water, and and we threw a couple stack lights on there, basically so you could see if we're on target or above or below target. And in a real world application, you probably would have some kind of ultrasonic sensor looking down through what's called a steel well, so you would not get the water rolling around effects, change and everything. But the amazing part, and I'm going to bring it up, is how quick it was to tune this. And basically what you're looking at on the software right now, if you want to go to the next slide, I think I got a couple. There's basically where I set up the PID. I won't go through that again. That's in one of the other videos. But here's the auto tune. I was really impressed with this because, I mean, I had everything running and it was kind of sitting there stable, and I put it in manual operation and I hit the auto tune start, and after 3 initiations of up and down, it found itself, and it actually, came up with the value for the proportional gain and the integral time. This particular application derivative really wouldn't do a whole lot for because of the slow response and everything that's required. And I should mention the stack lights. You'll see them blinking, but I have them set somewhat. Now Shane just changed the set point. Looks like he bumped it up to 520. We were setting at 500. And I should say I just threw numbers in here. I didn't take the time to, I mean, I scaled them, but I didn't take any time to actually come up with, so many inches of height or gallons or anything like that. But it would be very easy with the math instruction to actually, calibrate or calculate, if we wanted to keep that tank with so many gallons in there, it would be very easy to use some math in there to do that and everything. But as you can see here, we had a little overshoot, but right away, and what you're seeing is, the red at the top scale is the set point, the green's the actual level from the ultrasonic, and that bottom chart is actually the output, what it's doing. And as you can see, it came up pretty quick, it overshot a little bit, and then it settled down. I mean, for sure, the way we have this system, we can pump the tank up, but we actually are using gravity through a drain valve or a siphon tube to actually drain it, and we've actually put a petcock in there so we can adjust how much drainage we get. So that's another variable, and basically if I tried to tune this again, depending on where I set that petcock, I'd probably get slightly different values for the gain, proportional gain, and then the integral time. I think that's it. Hope you enjoyed today's demos. For sure we're going to have to come out with an advanced software programming 3 and 4, because there are a ton of other very powerful, helpful instructions within the Productivity 3000. We wanted to cover arrays and strings and mean time averaging, and there's just a ton of stuff we can do with it. And I think we got to have a bunch of other very informative overviews on the Productivity 3000 over the next couple months.
Now, Tom, there are some DataWorks little videos out on the Learn site that actually BizWare DataWorks guys did.
Yeah, they're very good. I think Ann, one of the employees, did most of them, and I actually used them to help me get up to speed on some of this and everything.
Tell you, if you want to watch those, go take a look at our Learn site. But there are some DataWorks ones. All right, we're going to stop and do our Q&A, and then we'll wrap up. So if you have any questions for us, go ahead and ask away. Select the little Ask a Question button on your tab. Ask any questions you have for us. We encourage any questions. And a couple of you, I'll apologize for that wrong hyperlink earlier, but I think we got everything straightened out. I didn't have any questions ahead of time on anything anybody wanted to see in particular. Most people just asking for PID, and I know, PID is going to be different on every application, but just showing them how easy it is to go in and set it up, and what you created with the demo over here.
Right. I mean, PID. I mean, I've done a lot of PID in the past. I mean, I date back to where I did PIDs and ladder logic in the long form, and and I was on jobs where literally to tune a PID on them. I mean, I was on the job for weeks, just trying to get it tuned and everything. So
I recall being in tech support and somebody trying to tune it with a handheld programmer.
Oh, jeez. Good luck. You're going to be there a while. But I mean, I'm just shocked the heck out of me how quick this tuned up for me. And we just threw something together that we wanted, there's so many different things you can do with PID, with temperature and
Sure.
airflow and everything else, but we kind of wanted to do something that was more visible, that you could see the level and change it and everything. So
there's a lot of people might not know about PID, what PID is, and I know we got some education groups in here watching right now, but I think one of the best examples, well, there's two examples. One of them's not a real good one, but let's just say the heat and the air control in your house. It's going to range a little bit, but it's not going to be dead on, right?
Right.
The best one to explain is going to be your cruise control in your car. That's going to give you the most accurate of what PID is. When you tell it, I want to stay at 65, that car is supposed to stay at 65, not 68, or you'll get a ticket. So that's what PID is. You're trying to keep some kind of level, temperature, flow,
So
whatever.
Car, you have some means to control your throttle, so you can increase or to back it off, and somehow you got some kind of sensor on your transmission or drive shaft that tells you your RPM and
Right.
all that good stuff. And then the worst part, even with temperature control in the house, is even like you saw in our little example, you want to be here and you increase your output to try to get there, and a lot of times you overshoot, so you need some way to anticipate when you're getting close, so you can start to slow it down and try to keep it. Now on the chart, if you want to flip back to the software screen just real quick, on this chart, it might be hard to see, but it looks like it's all over the place. But if you look at the values, we're within 1 or 2 points, and actually, we're looking at a range of 32,000 discrete points we can be looking at. So this kind of explodes it, but it's not as bad as this might look. I mean, it's actually holding a very tight tolerance for us. Yep.
All right, we actually have a couple of questions here.
Okay.
I'm going to call it out. If Tom and I don't know, maybe Lauren, one of our engineers, he can help out. Is there any plans to have a find, search, or replace options for editing in the software? Does it not have that? Because I know DirectSoft even has.
Within the...
Yeah, I don't know offhand where it's at. I know some of our other softwares do have it, and if it doesn't have it, they are in discussions with it, is what they're saying.
Yeah, to be honest with you, I mean, I've done a lot of stuff with the Productivity3000, as has Lauren, but so far, most of the stuff I've done, I've just gone in and thrown it in there and tested it and tried it.
Right.
So I haven't gotten into a huge program where I've needed to search for different things. And I mean, with the tag name database and everything, because you're using descriptive names and everything, it's easy to me to find stuff. But
I could have swore that they had something when we were going through training.
And to be honest with you, I'm a little lost right now. So that's...
Tell you what, the person that asked that question, I'll actually we'll contact you directly. I'll get a better answer and contact you directly.
Yeah.
And then they're saying maybe add a forward back browser type button in the software. So nobody else has it, but it'd be a big help when searching through the program.
That's a cool idea.
That would be.
Yeah, I mean, the one thing that helps with the task manager down here, as you're constructing your program and everything, I think this is great because I can break my program down into manageable chunks.
Right.
With descriptive names, and then if there's a certain procedure or something, maybe I don't want it running all the time, I can actually move it down here under the task manager and throw it into disable task or run when called or something like that.
Right.
So to me, that would help from the standpoint as I'm developing or troubleshooting the program. If I need to, if I'm looking at one screen or one set of procedures and then I go look over here, but I want to go back to that, But I agree, having a forward and back like a browser would be cool.
All right, we're going to go ahead and stop there. So thank you for the questions. If you have any more, though, please go ahead and you can ask before we close everything out. We'll be glad to answer. You can always email us, and you can always contact our tech support because they're free. And like I said, we'll get the information on that particular one and get back with you.